learning physics just got better. Watching that video, I discovered that I have offended a lot of people. Yes, I offended a lot of my students and my subscribers for going through that huge break. But honestly, I am back. Learn Fit is Better with Blessing is back, bigger and better. So I'm going to kick off straight. There's no time to check time. So I'm going to start with one of the fundamental concepts of physics which all physics students must understand. Measurements. Yes, measurement. First of all, what is measurement? Measurement is process of determining is the process of finding out or discovering the exact magnitude of something. And what is that something? That something can be a quantity, a physical quantity. What is a physical quantity? A physical quantity can be defined as a physical property that can be quantified through measurement. Physical quantities can further be divided into two. There are fundamental quantities and derived quantities. Fundamental quantities. From the English word fundamental, you know that it means basic and it means important and aspect of something. When they say something is fundamental, now you add the word quantity. That means fundamental quantities are those quantities that provide the standard unit of measurement, and they are seven in number. They are length, the mass, the time, temperature, luminous intensity, magnetic flux, current. So yes, there are seven in number. There are seven fundamental quantities. And derived quantities are quantities that can be derived through or that can be gotten from the combinations of fundamental quantities. That is through multiplication and division. Yes, and examples of derived quantities are pressure, force, velocity, acceleration, momentum, work, density, and so on and so forth. If you take note, you will notice that I'm mentioning some other topics that are in physics. Yes, like I said in the beginning, measurement is the foundation of physics. You can't mention any topic in physics without mentioning its units and its quantities, and that also branches out of measurements. Now move down to units. Units can also be divided into two, which are fundamental units and derived units. You can simply say that fundamental units are the units of fundamental quantities. That is, they are the standard units of measurements, while derived units are units that are derived from the combinations of fundamental units. Examples of derived units, or no, examples of fundamental units. Like I said earlier, fundamental quantities can be seven. So, and I also mentioned that you can simply say, for better understanding, that fundamental units are units of fundamental quantities. And examples of fundamental quantities are length, mass, current, and so on. So now we're just going to look for the units of those fundamental quantities. The unit of time is seconds. The unit of mass is kilogram. The unit of current is ampere. And now you understand what I mean by fundamental units are units of fundamental quantities for better understanding. But if you were to define it in the examination hall, yes, if you are to define it in the examination hall, it has a definition. Fundamental units are the acceptable units of measurement. You understand? Fundamental units are the acceptable units of measurement. Why I said that you can just say fundamental units are fundamental units are units of fundamental quantities is just for your own understanding. But if you're to define it in the examination hall, fundamental units are the acceptable standard units of measurement. Now let's move down to derived units. Derived units are They are also gotten from the combinations of fundamental units, just like derived quantities and fundamental quantities. And examples of derived units are acceleration. The unit of acceleration is meter per second square. We have pressure, is Newton per meter square. And yes, and now I hope you understand what I mean. And yes, before I forget, don't confuse symbols with units. Yes, do not confuse symbols with units. I'll take for example area. Let's look at the quantity. Area, the symbol of area is A in capital A. Now, why the units of area is meter square. That means area is measured in meter square. Why the symbol of area is just denoted. That means area can just be denoted by A, capital letter A. But in units of measurement, it is meter square. I hope you understand. Let's take for speed. Speed. The symbol of speed is S. Unit is meter per second. I'll give you a word, another example, which is density. Density. The symbol for density is P. The symbol for density is P. Its unit is kilogram per meter cube. So I hope now you understand the difference between symbol and unit. Please do not confuse them. Please do not confuse them. It's not when you want to write the unit of acceleration. Now another example. Not when you want to write the unit of acceleration, then you put like 5a. No, 5a is incorrect. Its unit is meter per second square. Out in another video, I'm definitely going to explain how those units came about. Of course, I will explain that. So that's all for derived units and quantities. By now, you should be able to define fundamental quantities and derived quantities, fundamental units and derived units, measurements, physical quantities, and also differentiate between symbols and units. In my next video, I'm going to be talking about another aspect of measurement, which is dimensions. Yes, dimension is another important aspect that you should know and understand. Turn on your notification button and subscribe, like, share to your classmates who will be interested in this video. Thank you so much for watching. I really do appreciate. Turn on your notification. We are treating dimensions. Don't forget to like, share, turn on your notification button, and subscribe. Thank you.